All right, I'll also upload these notes with my handwritten notes on them, obviously. So, all right, so let's begin. So, announcements. Homework 3 is due tonight by 11:59 p.m. If you don't have the book yet, email me and I'll send you a picture of the homework problems, but please get the book soon. It is required. And then office hours are like normal today. So come see me. Come see me if you're having any trouble with any of the homework problems. Okay. Homework 4 is posted and it's due next week at 11:59 p.m. It's pretty straightforward. It's going to be over stuff we learned this week. I'm continuously planning an exam for next Friday over all the stuff we're covering up to this week. Okay. So I will write up a review with problems that I expect you to be able to do on the homework, and I'll have that up to Canvas by the end of the week so that you'll know what you need to cover, what you'll need to know. Which Friday? Friday of next week. So Friday the 20, what next week? 21 plus 5, so 26th, is that right? Friday the 26th or 25th, whichever day that is. But next Friday, not this Friday, next Friday. Okay. And then no class this Thursday. My wife is having a surgery that I need to be there for. So no class this Thursday. This week we're only covering the product and quotient rules. We learned about the product rule last week a little bit. We'll review it today. And then the quotient rule. And then most this week we're going to focus on the chain rule, which is one of the most important rules for taking derivatives that you will learn. Okay, so any questions from anyone online? Yes, the 25th, thank you. Friday the 25th, continuously I'm planning an exam, okay? Any questions from anybody in person? My weekend was good. It was long but good. Yeah, my sister-in-law got married, so there was a small gathering that we went to, and it was nice.
You guys have to wear masks?
Yeah, we wore masks. Yeah. I'm not tangoing with no mask. Even small gathering, no way.
Oh, you're telling me.
Yeah.
I practiced this morning. We had to wear a mask. Like you have to wear a mask the whole time. People say you can breathe through it. Sorry. Yeah, it's a pain. I'm not gonna lie.
Any other questions before we start? Okay. All right, so last week we learned about the product rule. The product rule is the rule you'll use anytime you're taking a derivative of something like this, x squared times 1 plus cosine of x. Okay, so I need to use the product rule here if I'm taking the derivative of this, and the reason is, did I leave myself room? Yes, I did. The reason is if I'm taking f prime of x, well, one way to know if you need to use the product rule when you're taking a derivative is you read the function out loud. So when I read f of x, this is x squared times 1 plus cosine of x. If you ever have to say times for a function that you're taking the derivative of when you're reading it out loud, you're going to need to use the product rule, okay? So f prime of x, well, if we have, this is a product of this function, x squared, and this function, let me write that in red, and this function, 1 plus cosine of x, okay? So what's the derivative of x squared times 1 plus cosine of x? Well, the product rule says you take the derivative of the first thing and then leave the second thing alone. So what's the derivative of x squared? 2x. 2x, and then I'll leave the second thing alone. So 2x times 1 plus cosine of x. And then plus, then I take the derivative of the second thing. So what's the derivative of 1 plus cosine of x? Or what's the derivative? We'll do the hard part. What's the derivative of, well, let's do the easy part. What's the derivative of 1 with respect to x? 0. And then plus, what's the derivative of cosine of x? Perfect, minus sine of x. So plus minus sine of x. And then I'll leave the first one alone. Okay. So now I'll write this all in black. This is, and we can just leave it like this, 2x times 1 plus cosine of x. And then I'm going to bring this minus out here. So minus x squared times the sine of x. Okay. And that's the product rule. And so if I write it out, if I write out the product rule in general, what it was, the derivative with respect to x of f, I'll call it f1 of x times f2 of x. Well, again, this is just to take the derivative of the first thing, so f1 prime of x, and leave the second one alone, times f2 of x, plus, then you take the derivative of the second thing, f2 prime of x, and leave the first one alone, f1 of x. Okay? Everybody remember that? Cool. So, product rule, again, the way that I spot when I need to use the product rule is when you read the function out loud. If you have to say the word times, then you need to use the product rule when you take the derivative. Okay. All right, so today we're going to learn about the quotient rule. So the product rule helped us differentiate products. The quotient rule is going to help us to differentiate quotients. Okay, so it's going to help us differentiate something that looks like this: 1 minus x squared over 1 plus x squared. We don't have the tools to deal with this right now. We have the power rule. I can deal with each of those parts separately, but I don't know how to deal with the quotient of the two things. Okay, so today we're going to learn how to deal with this. So before we do that, we can look at the limit definition of the derivative just for a quotient. That proof is a little, it's another one where you use a trick. I'm going to do a slightly different thing. Okay, so first we're going to prove a simpler result. Okay, so let's say f of x is a differentiable function. Then we're going to show that the derivative of 1 over f of x, so the reciprocal of f of x, that this is equal to negative 1 over f of x squared times f prime of x. Okay? For everywhere that f of x is not equal to 0, because I obviously can't divide by 0. Okay? So this is the slightly simpler result we're going to show, and we're going to use that to bootstrap up to the quotient rule. Okay? So I want to show this result. So the only thing we know how to do right now is limit definition of the derivative. Okay, so I want to show d dx, the derivative with respect to x, of 1 over f of x is equal to this stuff. But the only thing that I know right now that this is actually equal to is the limit definition of the derivative, if it exists, right? So this is equal to the limit as h approaches 0 of what? Limit definition says You take whatever you're differentiating and you plug in what first? I'm going to plug in x plus h. You guys remember that? So everywhere I see an x, I'm going to plug in x plus h. So 1 over f of x plus h, right? And then what do I subtract off? Yeah, 1 over f of x, whatever I have written inside here. So 1 over f of x. And then I divide by what? H, perfect. We have questions on that. Questions from online. Perfect, Jet. Thank you. Yeah, we plug in 1 over, or we plug in x plus h. That's the thing we're differentiating. All right, so this does look like something we've dealt with before, right? How should I deal with this? What's the next step I should probably take? Get a common denominator. And again, it does not have to be the smallest common denominator. It just has to be a common denominator. So what is a common denominator of the two fractions in the top?
F of x.
Multiply their denominators, exactly. So when I do that, I'm going to end up with, well, I'm still taking the limit as h approaches 0 of, well, I'm going to multiply top and bottom here by f of x times f of x over x of f of x, and top and bottom here by f of x plus h. Okay, so when I do that, I get the limit as h approaches 0 of f of x minus f of x plus h divided by f of x times f of x plus h. And all of this is divided by h, right? Any questions so far? Yes, thank you, Saba. Okay, and then this is really over h over 1, so what should I do next? I've got a fraction divided by a fraction. Yeah, I flip the bottom, and then it turns into multiplication, right? So this is equal to the limit as h approaches 0 of f of x minus f of x plus h divided by f of x times f of x plus h times 1 over h. That was just me flipping the bottom and turning it into multiplication. Okay, cool. And now who sees what we should do? We need to do a little bit of rearranging to make this look like something that we know. Who knows what we should do? I've got an f of x minus an f of x plus h in the top, and here an h in the bottom. That almost looks like the derivative, right? But my sign is wrong. It's normally f of x plus h minus f of x divided by h. Okay, and so if I rewrite this a little, this is going to be equals to the limit as h approaches 0 of f of really negative f of x plus h minus f of x divided by h. So now I'm just combining that. I'm putting that over that. I'm going to put the 1 over times 1 over f of x times f of x plus h. Okay. So really all I did was I'll put it in red. I moved this so it was over this to make it look like the definition of the derivative. I put everything else over in another multiplication. Okay. Are there any questions about that? Yeah, exactly. Move the first part is what someone online said. And so now I've got a limit of a product. What is this part right here? Yes, this is exactly, well, negative f prime of x, right? Which is, from what I said, we know there's got to be a negative in here anyway. So this is equal to, this is negative f prime of x. And then what I have to do both parts of this limit. What is that part there? So remember that f of x is differentiable. So what can I just do with the h then? Or what should I try to do with the h? Yeah, you should just always try, if you know something's differentiable, then you know it's continuous. And so you can just plug in whatever the limit value is. Okay, so you should just try to plug in h equals 0. And what do I get when I do that? Yeah, I get 1 over f of x squared, right? This part is 1 over f of x squared. So it looks like as long as f of x is not 0, it looks like I'm getting negative f prime of x times 1 over f of x squared. Well, that's exactly what we started to show, right? That's exactly what we wanted to prove. Okay, and for anyone who's taken this class before, maybe, and it's okay if you have, who cares, then this should remind you maybe of another rule you know that you've seen. And this is kind of like a little baby version of the chain rule that we're going to see later this week. Okay, so so to make it perfectly clear, this is negative, I'm going to write it as just negative f prime of x over f of x squared, like that, which is what we wanted to show. So I use this result. And why did I show this? Who can maybe think of why I showed this instead of going directly to differentiating f of x divided by g of x? In the limit definition, I would have a whole nother function to deal with. But now, when I'm trying to find the derivative here, what kind of rule could I maybe use to work around? I don't want to give away the answer, but I'm going to. So f of x, really quick before I write down what this derivative is going to be, f of x divided by g of x, this is just equal to f of x times 1 over g of x, right? So this was the whole reason I proved that sort of simpler result, is now instead of proving the quotient rule from scratch, I can use the product rule with f of x and 1 over g of x, because now if g of x is differentiable, we know how to handle 1 over g of x when I take a derivative. Okay, so that was the whole reason I proved that simpler version of the quotient rule, so that we can use it to build up the real version of the quotient rule. Okay, so delete. All right, so the quotient rule, if I want to take the derivative of f of x divided by g of x, where g of x is not 0, then that derivative goes as follows. The way most people, it's a dumb way to remember it, but if you call the numerator, if you call that high, and if you call the denominator, you call that low, then it's low d high, so g of x, f prime of x, minus high d low, and when I say d, that means take a derivative. So minus high d low over the square of what's below. So it rhymes. Wonderful. So this is low d high minus high below over the square of what's below. So below squared. Dumb, it rhymes, it'll help you remember. It helps me remember. All right, so let's prove this. Here we go. So, like I said, we're not going to use the limit definition. We're not going to use the limit as h approaches 0 of f of x plus h over g of x plus h minus f of x over g of x, all divided by h. We're not going to do this. This would be the limit definition of the derivative of f of x over g of x. We're going to use stuff we already know to prove this. So I'm going to say f of x over g of x is equal to f of x times 1 over g of x. Okay, and then I'm going to take the derivative using the product rule. All right, so dx of f of x times 1 over g of x. Well, the product rule says take the derivative of the first thing and leave the second thing alone. So I'm going to get f prime of x times 1 over g of x. Then I'm going to add, well, I'm going to take the derivative of the second thing, which we just saw was negative g prime of x over g of x squared. There's the derivative of the second factor. I'm going to leave the first factor alone. Okay, so technically we're done. I'm going to move things around a little bit to make it look like what I have written in the theorem box, but technically that's enough. We've taken the derivative. But let's make it look a little more like what I wrote before. So the denominator here is g squared. The denominator here is just g of x. So I'm going to multiply here, top and bottom, by g of x over g of x. Okay, so when I do that, I'm going to get f prime of x times g of x minus, it looks like an equals, minus g prime of x times f, times f of x, and then our denominator is g of x squared. And that's exactly what we wanted to show. So in doing a simpler quotient rule, proving a simpler case of the quotient rule, we were able to use that to very quickly prove the general quotient rule. And that's kind of a theme of, if anyone wants to be a math major, which you all should be, math is the best. If you want to become a math major, sometimes the general theme in math is if you want to prove kind of a hard result, we'll prove an easier result and use that result to bootstrap up to the hard result, which is so fun. I think it's the coolest thing. Okay, so do we have any questions about the quotient rule before we see some examples of it? All right, so let's use the quotient rule to find the derivatives of the following functions. F of x is tangent of x. We're going to prove that, and we're going to prove the rest of the trig derivatives today, by the way. G of x is 1 minus x squared over 1 plus x squared, the example I first showed at the beginning of this lecture. And then h of x is x cubed minus x plus 1 over 4 minus x. Okay, so let's take these derivatives. Oh, excellent question. Someone asked, do we need to memorize the proofs? No, I'll say know how to prove the derivative of something exists from the limit definition. But I'll only give you limit definition questions probably on like polynomials. I don't think I will ask you to prove, I won't ask you to prove the quotient rule from the limit definition, okay? Excellent question. All right, so we want to find the derivatives of these functions. So let's find the derivative. Why is this one here? We just learned about the quotient rule. That's not a quotient, is it? Huh? Ah, perfect. I'm tricking you. It's sine of x over cosine of x. Sine of x over cosine of x. But nobody fell for my tricks. Yes, this is a quotient in disguise, right? Tangent of x. All right, so let's show that what the derivative of tangent of x is. So I want to take the derivative. So this is number one. I want to take the derivative with respect to x of tangent of x. So that's just the sine of x over the cosine of x. All right, quotient rule. So again, even if you don't want to remember it this way, I'm going to force you to remember high and low. Okay, so the quotient rule says low d high. So what is that going to give me? First of all, what is low? Yeah, cosine of x. And then d high. So what's the derivative of the top?
Cosecant?
What was it?
Cosecant?
Careful. Sine and cosine bounce back and forth between each other. Okay, so that's something to remember. Is that derivative of sine is cosine, not cosecant, but you're close, definitely. And the derivative of cosine is negative sine. Okay, so sine and cosine bounce back and forth between each other, and you need to introduce a negative when you, again, take the derivative of something that starts with a C. So here I'm going to get the derivative of sine. Well, that's cosine again, so I'm going to get cosine squared x here. Which you might see, by the way, you might see in your book, or I might write it this way. This is, people write this as cosine squared x, like that. So if you ever see that, that just means cosine of x, the whole thing squared. All right, so then minus, we did low d high minus high. So what's high? Sine of x. D low, so what's d low? Negative sine of x, perfect. So I'm gonna get, this is really gonna be, I'll write it out to be safe. Times negative sine of x over, oh, oops, sorry. Yeah, what was it? Cosine squared, perfect. Cosine of x squared, perfect. Let's see what the online people said. Perfect. All right, so what does the top become? This is just cosine. I'm going to write it like your book writes it, because everyone writes it like that, cosine squared x. Sine of x times negative sine of x is going to be negative sine squared x. So when I take the minus and negative, it's going to turn into plus sine squared x. And this is divided by cosine squared x. And then who knows what sine squared x plus cosine squared x is? That's just 1. And that comes from, you could scream SOHCAHTOA. I mean, if this is x here, then opposite adjacent, we'll take this to be 1. Sine squared x then would be O squared, cosine squared x would be A squared. So it's just the Pythagorean theorem. 1 over cosine squared x. Okay. And lastly, we can rewrite this 1 over cosine of x is what? Does anybody know? Yeah, secant. Yeah, so 1 over cosine is secant, so 1 over cosine squared x is secant squared x, which we write as secant squared x. And that is our answer for the derivative of tangent of x. Okay. Questions on that? All right. So let's look at number 2 now. For number 2, we were taking the derivative with respect to x of 1 minus x squared over 1 plus x squared. All right. Again, this is high. This is low. So what am I going to get with this derivative here? 1 plus x squared. Good. There's low. I think you said it. Oh, so close. What's the, because the derivative of 1 though is 0. So it's just the minus 2x. Okay. Yeah. So that was low. And then d high is negative 2x. So there's low d high. Yes, thank you, Saba. She said d high, which is exactly right. Minus, all right, now we have what? High, so 1 minus x squared times 2x, d low. And then over, yes, over the square of what's below. So 1 plus x squared all squared. Don't forget that second squared. I guarantee some of you are going to, yeah. Nope, no, careful, because 1 plus x squared, excellent question. You need to FOIL this, right? This is really 1 plus x squared times 1 plus x squared. Yeah, good question. If you want to expand this, you can. I'm going to say that I'm not going to say never expand it. I'm going to say almost never expand something like this. There are times when you will need to simplify, but usually you'll just be able to cancel right away. Yes, excellent question. So I'm going to leave this as just 1 plus x squared all squared. Okay, and then you should simplify the top. So when you do that, we're going to get, well, we distribute this here and here. So I'm going to get negative 2x minus 2x cubed. And then I'm going to get minus, well, I'm going to get 2x. So minus 2x and then minus 2x cubed over 1 plus x squared squared. So then this is equal to, well, I'm going to have minus 2x minus a 2x. So that's going to give me what? Yeah, negative 4x. And then minus 2x minus 2x, huh? Yeah, so plus 2x. Yeah, exactly. These cancel, right? The minus 2x cubed cancels with the plus 2x cubed. And if you want to write all of this out, that's perfectly fine also. So, but I'm only left with in the top negative 4x. And in the bottom, I'm still left with 1 plus x squared all squared. Okay. Any questions on that? Okay, cool beans. And then the last problem, x cubed minus x plus 1. I'm going to just go here. 3. X cubed, So we want d dx of x cubed minus, what was it, x squared, minus x plus 1 divided by 4 minus x. All right, so again, high and low. So, well, what rule am I using to differentiate this? Yeah, quotient rule. And just like with the product rule, the trick I used to remember that I need to use the product rule, read the function out loud, it's the exact same thing here. If I read this function out loud, x cubed minus x plus 1 divided by 4 minus x, if I have to say divided by, that means I need to use the quotient rule when I'm taking the derivative. Okay? So I've got high and I've got low. So the derivative, according to the quotient rule, is what? Perfect, yeah, so low, 4 minus x times 3x squared, don't forget that squared. 3 comes down and you subtract 1 from the exponent, right? And then, so that was the derivative, yeah, and then minus 1, perfect. Minus 1. So there's low d high, and then I need to subtract off high d low, so minus high x cubed minus x plus 1, and then d low, what's the derivative of the bottom? Just minus 1, right? So I'm just going to change this into a plus. Is everyone okay with that? And then over the square of what's below? Well, that's just 4 minus x squared. Okay, and then you should simplify. So we're going to distribute here. This is 4 times 3x squared. Well, that's 12x squared, and then minus 4, and then minus 3x cubed plus x, and then plus x cubed minus x plus 1, all divided by 4 minus x squared. Okay, and then so lastly we have, let's combine some like terms. We have an x cubed and a minus 3x cubed is going to give me, yeah, minus 2x cubed. Perfect. X squared, I only have one of those, so plus 12x squared. This x cancels with this minus x, and so I'm left with minus 4 plus 1. Well, scientists tell me that that's minus 3. And all that is over 4 minus x squared. You guys are doing great with this, by the way. Quotient rule is normally like people freeze up. Questions? So now we have the tools to handle most, but not all of the functions that we've just seen in the wild. We're going to see in, we're going to see tomorrow how to handle a function that looks like the square root of 1 plus x squared, something like that. We still don't have the tools to deal with that. But after tomorrow, we will. All right, so a quick word on deciding which rule to use of the rules that you know. So to decide which rule you need to use in differentiating a function, try reading the function out loud. Okay, if you ever have to say the word times when you're reading the function out loud, then you'll probably need to use the product rule. And if you ever have to say divided by, you'll probably need to use the quotient rule. Are those two mutually exclusive? You should ask me. And I'll say no. You might need to use multiple rules within one derivative problem. For example, if you're taking the derivative of x times tangent of x, or x times sine of x over cosine of x is how we would rewrite that, right? Well, then to take the derivative of the top with the quotient rule, you have to do low d high. You need the product rule inside that derivative. And then for the whole derivative, you need the quotient rule, right? So it's not mutually exclusive. You might have to use multiple derivative rules to take a single derivative. Okay? And I'll show you, we'll look at examples where that's the case. Yes, yeah. Someone asked if I could provide a refresher of trig rules and stuff like that on Canvas. I'll post something like that to Canvas so that you guys can look at some refreshers on trig definitions and identities that you might need. Okay. So let's look at some examples. Find the derivatives of each of the following functions. All right, we've got this function f of x is x to the fourth minus 3x times x cubed plus x plus 1. Number 2, g of x is 1 over x to the 17, or 1 divided by x to the 17. And then 3, h of x is equal to the cotangent of x, which I have in parentheses, that's cosine of x over sine of x. All right, so we need to decide for each of these which rule we need to use to take the derivative. Okay, so let's look at number 1 first. Number 1, I want to take the derivative of x to the fourth minus 3x times x cubed plus x plus 1. And so what rule am I going to need to use there? Product rule, right? Really multiple rules because I need to use the product rule, and then within the product rule, I'll need to use the power rule, right? So, but yes, that's exactly right. We're taking the derivative of something times something else. That's the product rule we need to use. So f prime of x then, well, product rule says, I'll color code things. I'm going to take the derivative of the red thing first, and then leave the blue thing alone. So derivative of the red part. What's the derivative of x to the fourth minus 3x with respect to x? 4x cubed minus 3, perfect. So really, there's 3 rules in one, because we have the rule for taking the derivative of a sum as well. It's just you take the derivative of each part separately. So there's the derivative of the first function times, leave the second function alone, x cubed plus x plus 1, plus, then I take the derivative of the second function first and leave the first function alone. So here, blue is second. So what's the derivative of the blue function with respect to x?
X to the fourth.
3x squared plus 1, right? I think someone online said that. Thank you. Yeah.
I guess I'm still a little confused on like how is it just plus 1, not plus x plus 1? Is that because like when you take the derivative, it's like a 1?
Yeah,
Okay.
exactly. Yeah, you take the derivative of each term in this separately. So the derivative of just x cubed, that's 3x squared. Then because I'm adding, when I take a derivative of something plus something else, then you just take each derivative separately and you add them all up at the same time. So derivative here is just plus 1, and derivative of that is 0. Yeah, excellent question. Yes, so this, yeah. So even better, this 1 is not, it has nothing to do with that one. It only has to do with that x there. Okay.
So it's only like when there's a variable, basically?
Yes.
Okay.
Yeah, absolutely. If there's no variable, when you're taking a derivative, if you're just adding a constant, that part of the derivative is going to be 0. Absolutely. Okay, and then so that was the derivative of the blue part, and then I'm just going to leave the red part alone. X to the fourth minus 3x. Okay, and then you can distribute this if you want. If I don't ask you to, then don't. The whole point of the product rule is to avoid having to distribute a bunch of crap, so that you don't have to distribute all this and then take a derivative and then maybe factor some stuff. No, we just want to leave it like this most of the time. It does depend on the context of the situation, but if I just ask you to take a derivative, you did. You're done. Now you use the product rule and you're done now. Okay, so this is our answer. Okay. Questions on that? All right, really quick. Number 2, what rule would we use? Aha, yeah, I didn't trick anybody. I was trying to trick you because you just learned the quotient rule. But this is, if we rewrite this, g of x is x to the minus 17, right? So for this one, I would just need to use the power rule. You could, if you want, you could use the quotient rule, because they are the exact same thing in this case. It's just a little bit more work to do low d high. And the reason it would be the same is because d high here was the derivative of just 1, and that's going to give you 0. So the first part of the quotient rule is going to give you 0 minus high d low. It will all work out so that you get g prime of x is negative 17 x to the minus 18, right? And you're done. Yeah. Power rule. Okay, so being able to recognize which rule you need to use is a very it's an important skill. It's going to come a little bit with remembering some of the tricks that I showed you, and it's going to come a bit with practice, with doing a lot of these problems and recognizing what kind of tricks someone's trying to throw at you and how you should respond. Okay, so 1 over x to the 17, that's a classic trying to trick you into using quotient rule, but you really just need to use the power rule. All right, so we'll pick up from here tomorrow and talk more about the quotient rule, higher order derivatives, and hopefully we'll get into the chain rule a little bit. And then the rest of the week is chain rule stuff. Okay. Any questions in person or online? Cool. Please make sure to wipe down your desks as you go. And thanks to everybody for being here.
Thank you.